Hello, my name is Rob Reynolds, and this is College Algebra, Section 1.4. Today, the topic is going to be solving radical equations. And when you solve a radical equation, we want to undo what's happening to x. And in this case, we can't add 1 because of the radical, and we can't divide by 3 because of the radical. So the first thing you always want to do for radical equations is try to isolate the radical, get the radical all by itself. So in this case, we're going to add 2 to both sides. So I'll end up with the cube root of 3x minus 1, and I'll throw the 2 on the other side. The next step is to cube both sides, because the cube root of anything cubed is itself. So on this side, I'll have just 3x minus 1, and on this side is 8. Finishing this up, 3x equals 9, therefore x equals 3. This one, to isolate the radical first, so I'm going to subtract 4 from both sides. So 2x minus 5 is equal to x minus 4. The next step is to square both sides. And again, the square root of anything squared is itself, so this side is just 2x minus 5. Be careful on this side. The mistake is students will try to distribute this, and that's not true. That's the #1 mistake in mathematics. You could FOIL this out, x minus 4 times x minus 4, but this happens so often that instead of FOILing, which takes a long time, here's your first term, here comes your outer terms, here comes your inner terms, here comes your last terms, and then you combine. That just takes way too long. So there's a shortcut, which I'd like to teach you, and hopefully you can use. The shortcut says square the first twice this product. Well, the product of x and -4 is -4x. So I'm going to double that for -8x, and then square the last. That's the rule that I'd like for you to use and get used to. It's much faster. So setting this thing equal to 0, I'll get x squared. Subtracting off 2x minus 10x and adding 5 is 21. Factors of 21 that add up to 10 are 7 and 3. This says signs are alike. They're both negative, x minus. So x equals 7 and x equals 3. Now we might have some extraneous solutions. Extraneous solutions happen when we get a solution, but it simply doesn't check. So let's check the 7 really quick. 2 times 7 is 14. 14 take away 5 is 9. The square root of 9 is 3, and 3 plus 4, I'm checking to see if that's equal to my x value, 7, and it is. So 7 works, but let's check the 3. 2 times 3 is 6. 6 minus 5 is 1. The square root of 1 is 1, but 1 plus 4 is not equal to my x value, which is 3. So no, this is not true. 5 does not equal 3. So this is called an extraneous solution, and I'll throw that out. In this course, I've asked you to purchase a graphing calculator, and I'll show you how to check your solutions on the graphing calculator. Go to your y equals up here, and I'm going to type in the function second square root 2x, the x key is underneath the mode, minus 5. I'll add the 4, and I'm going to subtract off this x to the other side and set it equal to 0. So I'm going to look for the zeros here. Please hit zoom 6. That'll give you a standard 10 by 10 by 10 graph. And I can see on this function that the only solution here is 7. To check that answer, to see if 7 is the solution, I would recommend you hit trace 7, enter. And that'll give us the y value is a 0. If we test the 3, we can see that the y value is not 0. In this case, the y value is 2. So the only solution here is the 7, which is here, 7, comma 0. So it's very easy to check for extraneous solutions using your graphing calculator. On this one, again, we're going to square both sides. The radical is already isolated. And be careful. The trap over here, again, is you cannot distribute this side. We're going to have to use that shortcut rule. The left side's pretty easy because the square root of anything squared is itself. So on the left side, we're just left with x plus 1. I'm going to show you this rule one more time. We're going to square the first. So the first term is negative x. So negative x squared is x squared. We're going to double the product. Well, the product of negative x and 1 is negative x. So if I double that, I have negative 2x, and then square the last. So again, the rule is square the first, twice the product, square the last. Setting this equal to 0, I end up with x squared minus 3x, and the 1's will cancel if I subtract 1. This I am not going to factor like I factor a trinomial. This time I'll actually pull out a greatest common factor, which is just x, leaving me with x minus 3. And don't forget that this term, x, can also equal 0. So that's actually a solution that I'll want to check. The other solution that I want to check is x equals 3. So remember, you're not done until we check our solution. So let's plug the 0 in. 0 plus 1 is the square root of 1. And 0 plus 1, and 1 equals 1, and I think that checks. So I think 0 is a good solution. Let's try my 3. 3 plus 1 is 4, the square root of 4. Let's check to see if that's equal to negative 3 plus 1. No, 2 does not equal negative 2, so I'm going to throw that solution out. Again, you can graph that on your calculator as well. So remember, these are called extraneous solutions. The first 5 letters of extraneous are extra, and that's exactly what it means. It's an extra solution. You can just cross it out on your calculator. This particular problem, you do not have the radical isolated by itself, so we want to take this term and throw it on the other side. I'm going to get some radicals on the left and some radicals on the right. So the first step here is to add the square root of x to both sides. Our next step is to square both sides. So the square root of anything squared is itself, so 5x minus 1. I am not going to distribute. That's by Big Noper. Don't do that. That's a trap. Instead, I'm going to use that rule that I gave to you, which is square the first, 1 times 1, twice the product, square the last. Set this equal to 0. Actually not, because I see that I've created another radical term. And the rules for radical is to isolate the radical, get the radical all by itself. So instead of setting this equal to 0, I think I'm going to isolate that radical term instead. So I'm going to throw the 1 over. If I'll subtract off 1, I'll get negative 2. And I'll subtract off x as well for a total of 4x. And I have another radical. And I know how to solve for radicals by squaring both sides. But instead of squaring both sides first, I'll show you a trick. If you could simplify this problem, it makes the numbers a little bit nicer. I'm going to divide everything through by 2, so I'm just left with the square root of x is equal to 2x minus 1. And then I think I'll square both sides. I could have squared both sides when it was back to 2 square roots of x, but again, I think it makes the problem just a little bit easier if you simplify first. So on the left side, I'm going to not distribute. Don't do that. Instead, I'm using my rule, which is square the first, twice the product. Well, the product is negative 2x, so twice that is negative 4x. And then square the last. And then the square root of x is just x. So now I'll set it equal to 0. And I will look for factors of 4 and 1 that add up to 5. So factors of 4 and 1 are probably, let's look. Oops, that's a 1. So your factors are going to be, let's see, 1 and 1 is, 1 times 1 is 1, and 1 times 4 is 4, and I think 1 and 4 adds up to the middle term 5. So I think I'm going to use this 1 and 4 as my first terms. So I'll have a 1x and a 4x. And then the next thing I want to do is look to see what this 1 lines up with, because after first terms in the for method comes outer, and it looks like I've done the work for me out here. Looks like I should be lining up the 1 with a 1. And the 4 also goes to a 1, because the only factors of 1 that exist, remember my last term, my last term has to be, technical difficulties here, my last term needs to be a product of 1 as well. So this was kind of an easier problem. But this says signs are going to be alike, and they're both negative. And so now I'll end up with x equals 1, or x equals 1/4. Now this is kind of hard to check, so I'm going to go back to my calculator and see if I can check these on the calculator. So notice again that I'm taking this one and I'm going to throw it on the other side, or subtract off 1 from both sides. Type this in. I'm going to hit zoom 6. That'll give me a standard 10 by 10 screen again. And I'm going to check my solutions. Now remember, my solutions that I'm checking are positive 1. So I'll try, hit trace 1, enter. And that looks like it should work. There's my 0. And let's test the 1/4. I'll just hit the 0.25. You could hit the trace key again if you wanted, but don't have to. And you can see clearly, no, the 1/4 does not give me a 0. So again, type this under your y equals, hit zoom 6, and then trace whatever answer you get. And it looks like 1 is going to be a great solution. For this one, you might want to do some u substitutions. And I don't think I've shown this to you before. So the u substitution is, I really like for this to say u squared minus 3u plus 2, because it would be easier to factor. So in this case, I'm going to let my u be this center term, which is x minus 2. So if we let u be x minus 2, then notice if I square both sides, I get x minus 2 quantity squared for my u squared term. So to factor this, I'm not going to factor it in terms of x, I'm going to factor it in terms of u's. So factors of 2 that add up to 3 are 2 and 1. Signs are alike, they're both negative. U minus 2, u minus 1. And if I solve for u, I get u equals 2 and u equals 1. But remember, I have a value of u. U is really x minus 2. So I have answers for u, but I also have answers for x. X should equal 4. And over here, if I substitute the u back in for x minus 2, I get x minus 2 equals 1. So therefore, x should equal 3. Little trick to solve. It's called a u substitution. Over here, my u substitution would be that middle term, the square root of x. And we can test it, because if you square both sides, I get u squared is equal to x, which is exactly what I wanted for the first term. So if I do my substitutions correctly, x is my u squared, negative 5 times this term, which is not the square root of u. I'm going to use the u substitution. So I'll plug in a u. Oops, this is a minus here. So u squared minus 5u plus 6 is equal to 0. So again, factoring this in terms of u, factors of 6 that add up to 5 are 2 and 3. Signs are alike. They're both negative. So u either equals 2 or u equals 3. And I'm going to go back in and use my u substitution, which really says the square root of x equals 2, or the square root of u equals 3. So squaring both sides, I get x equals 4 and x equals 9. You'll want to check for extraneous solutions here. On this one, the u substitution, again, middle term, t to the 1/4. Let's test it. U squared should equal t to the 1/4 squared, which it does, because that's t to the 2/4, and t to the 2/4 is that first term. So this becomes, again, my u squared term plus 8u plus 16. I'm going to factor this and then do my u substitution. So factors of 16 that add up to 8 are 4 and 4. Signs are alike. So I'll have u plus 4, u plus 4, which is u plus 4 quantity squared. Take the square root. U plus 4 equals 0, so u is negative 4. And my substitution says t to the 1/4 is equal to 4. To solve for this, I'm going to raise both sides to the 4th power. And t will equal 256. For the next example, I would have to solve for 0, or set it equal to 0 first. And probably pull out an x and continue factoring. Let's see, x squared minus x minus 2, and then factor some more. And then for the last example, I haven't shown you an example of this, but this is a factor by grouping. So the first two terms, I'd pull out an x squared. I'd try to get another x minus 3, and think about what goes in this blank so that I can multiply it by x and get a negative 4x. And in this case, it's going to be negative 4, and I'll check it. Does negative 4 times the negative 3 give me the positive 12? And the answer is yes, it does. If it doesn't, we have to do synthetic division. So now I've created some more GCFs. So I've got an x minus 3 and an x minus 3 for both terms. So I'm going to factor out an x minus 3. leaving me with the two terms. So if this term gets factored out and this gets term factored out, I have an x squared minus 4, which factors some more.